Imagine you have $1,000 and I offer you a bet using a coin flip. Heads, you double your money. Tails, you lose all of it. Here's what could happen if you bet all your money on every coin flip for multiple rounds. You start with $1,000. If it's heads, you now have $2,000. But if it's tails, you're out of money. On the next flip, heads means you have $4,000, but tails means you're out. It's easy to see that even if you get lucky and get heads the first few times, eventually you'll get tails and you will lose everything.
All in. 6 million.
Bet 6 million, all in. 5 million, all in. Bet is 6 million.
Race.
Raise 12 million. Heads up.
This is the classic trap of the all-in mentality. We see it in movies and high-stakes poker, where the hero risks everything on one turn of a card. It's exhilarating, but in the real world of probability, it's a death sentence for your bankroll. Even if you have a 99% chance of winning, if you play long enough and bet everything every time, your probability of eventual ruin is a staggering 100%. The math doesn't care about your winning streak. It only takes one tails to reset your progress to zero. It's obvious that you shouldn't bet all your money, but should you take the bet in general with some amount of money? To answer that, let's look at all the scenarios. Consider what would happen if you played 3 rounds of double or nothing. There are 8 scenarios that are equally likely, such as heads, 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 tails, heads, tails, and so on. If we check out what happens when we examine the row as a whole, we see that sometimes you'd win and sometimes you'd lose. But what happens in general? What can we reasonably expect? If we add each outcome up and divide by the number of scenarios, we get an average of $1, which is what we started with. Statistically, we shouldn't expect to make any money here. Great if you want an adrenaline rush, though. Let's look at a similar chart for triple or nothing. Notice how in this case, the average after the first bet is more than what we started with. This is great, but we still run into the original problem. It's only a handful of folks at the end that win big, while everybody else ends up with nothing. So what can we do? This triple or nothing scenario is what gamblers call a positive expectation game. On paper, it looks like a gold mine. If you could play this game an infinite number of times with an infinite bankroll, you'd be the richest person on earth. But you don't have infinite money. You have one life and one bankroll. This creates a weird paradox. A bet can be mathematically good for a group of people on average, but devastatingly bad for you as an individual if you don't manage your risk correctly. Well, you might be thinking, gee, why don't you just not bet every penny you have on a bet where you could lose everything? Great point. But the question is, how much? What's the optimal amount? The answer is that it depends on how much you have. You don't want to bet everything because that's dangerous, but you don't want to bet nothing because there's money to be made. You want to be somewhere in the middle between everything and nothing. One good approach is to always bet a fixed percentage of your bankroll. The less you have, the less you bet. Hence, when you inevitably hit a losing streak, you protect yourself from losing everything. You want to still be in the game to enjoy the wins when it all averages out. By betting a percentage rather than a flat amount, you create a safety net. If you lose half your money, your next bet is automatically smaller, which slows down your losses. Conversely, as you win, your bets get larger, allowing you to compound your gains. It's a way of scaling your ambition with your reality, ensuring that no matter how many tails you hit in a row, you're never truly out of the game. So what percentage should that be? It turns out there's a formula. Enter the Kelly Criterion. Here's a simplified version. F equals P minus Q divided by B. Those are probably meaningless letters to you at this point, so let's break it down. P is the chance that you'll win, which was 50% in the last 2 scenarios. Q is the chance that you'll lose, also 50%. B is the profit you'll make from the bet when you do win. In Double or Nothing, that's $1 because you bet $1 and you win $1. In Triple or Nothing, it's $2 because you bet $1 and you win $2. Using Kelly on Double or Nothing tells us that we should bet 0% of our money, which confirms what we saw a few minutes ago. It's a bad bet. Using Kelly on Triple or Nothing gives us 0.25. In other words, bet a quarter of your money every time. Pretty cool, huh? What's the catch? Well, Kelly does have some weaknesses. First, it's bold to assume that you know your exact chance of winning or how much you'll win. If you're off by a little bit, you can end up making some really bad bets. Second, Kelly doesn't account for your own risk tolerance. How much you bet could be mathematically the best option, but you could have terrible luck and maybe you don't have the stomach to lose half your money in mere seconds. A common solution to both these weaknesses is to bet a fraction of the fraction. Half Kelly is common. For example, with Triple or Nothing, that would be 1/8 of your money, which is 1/2 of 1/4. This gives you a massive buffer against both bad luck and bad data. Finally, if you're curious about the math for deriving the formula, drop a comment. If enough people are interested, I'll do a follow-up video. And that's it. Thanks for watching.